this step-by-step guide to pipe stress analysis. I have this demo Caesar 2 2019, so I'll open it. Then I have the isometric that I want us to use for the purpose of this training. Okay, so this is the line we are trying to model on Caesar. And we have the design condition here. Design temperature is 38 degrees and operating temperature is ambient. We have design pressure 19 bar gauge and the operating pressure 15 bar gauge. Test pressure 28.5 so bar gauge. So from your isometrics you have all those details, and if you want more, when you need more information, you check your P&ID. So let's go back to our Caesar file. So we can set from here, we can set up our unit. These are other configuration category that you have. Computation control, but I don't want to go into that. That will be another lecture. This is the unit file that I use is English. You have other mode that you can use. You can see bar fill. Choose bar fill now to change to bar fill. So apply. That will be bar fill. Since our pressure is less, let's use that. Then we create new pipe. Our pipe is what size? I hope the demo will be able to take a 3-inch pipe. That's the size of a pipe. Why is it 3-inch? And okay, yeah, it's 3-inch pipe. That's a reducer here. So I think we can start with 6 because we start with a reducer, a flange, a reducer to 3. So let's start. If you look at the ISO, look at the plant knot. This is it. This is a knot. So you look at your Caesar after. So let's just say 6-inch. The line is 3-inch. Let's do the line. You can put the line number if the line number is stated there. Okay, it's not, so no problem. You can check that on your P&ID and put the correct line. Let's say XS01 for instance. So okay, then to open up the units that you are using, SI bar, there you have your length in 25 mm, you have the force in Newton, you have the that's the weight in kg, and some other thing, the pressure in bar, which is good. No, once you select select the unit you want to use, select the unit from the unit file. Once you select the unit, then you have that. So now that we have our unit, the length, the node is to help us create the elements, the pipe, the elbow, the rigids are the valves, the flanges, and other items. So we give them node from one node to the other. So and our node range is 10 to 20. It is good to choose 10 to 20 because if you want to insert an object, it will be easier for you to still choose. You can still use 10 to 15 or 10 to 12, so have more leverage on nodes or node numbers. Now, so we have the diameter is 6 because It's starting from a flange of 6 inch, then the reducer. Okay, because this is a demo, so we have to forget the 6 inch. You can only do limited to diameter of less than 4.5. So you can use 4, that 4, no problem. So just to represent it, our 6 now is 4, this is 114. Schedule is a standard. If you check your ISO, check the pipe material. Come here. Oh, this is JIS, but for the sake of this class, let's use carbon steel. That's class A 106. So I'll choose that. Type A, press enter to select the carbon steel A grade B. Where is it? So now from the ISO we have a flange. So and this is the flow direction. Look at the flow direction. So it's flowing towards south. South. So we have flange. We create our flange. Look at our. Let's do it in such a way that our knot will face. Okay. We remove this so that the thing will not be changing. This is view reset, so that will not be reset to default. So that we have the knot now facing like this. So our sorry. So we have the flange on Z. Just click, go to flange. It's 150 pound. Select flange. Copy to Z. Are you seeing it? This is not. So the Z is the south. It's coming this way. You understand? So now the next one, to go to next, you see the next sign. That's continue. Click continue. Then we have what's the length of that reducer? It's not stated here, but we can get it from pipe data. You go to your pipe data. Go to reducer. Concerted reducer. That's 4 by 3. That's 102. Okay. So 102. You go to your scissor file and you click. You put 102 here. And then select reducer. The diameter 2 is going to be 3 because reduced to this. So and the thickness standard. You can leave this. So now we have it. Then you go to your ISO again. Now look at the length from the flange to there's something here that I think the designer did not put correctly. There should be there's a support here and the length is not given, so we cannot locate it. So now what we'll do, we have to assume that maybe it's in the middle of the pipe. let's say from here to here is the spool from here to here to the support, let's say it's 1 meter. Okay, so just continue and put 1 meter. Then at the end of the 1 meter, we put our restraint, that's the support. This restraint will be defined the type of restraint it is. From that, so you have your GA, you have your pipe schedule. But for the purpose of this, let's just we are not going to the detail of those. In another lecture on pipe support, we do detail of support. So, but let's just represent it by Y. Whereas in our in the other video, in the other lecture, we're going to discuss pipe support, different type, and how they are represented in scissor. So this is it. Then from there, since it's 1.5 something, let's say from here to the, there's a T here, there's a branch here, so 500. Good. So next, then 500 mm. Then the branch is SIFs and T's. So it depends if it's a flat, if it's welded, if it's welded, butt weld, circlet. So, but you check from your ISO, what's the line? F5. It's still 3 inches, so it's 3 inches. It's welded. Then you go to the next one, the end of the T. That one you can get it since it's in an equal T. Go to your pipe data, check your equal T. 3 inch equal to, that's the length from here to is 86. So that's me from here to here 86. So you select, say continue, and put 86. Then we have another reducer. So the reducer is reducing from 3 to 2. Check your pipe data and go to reducer. Three to 2 is 89. So we go, continue, 89. Select reducer. The next one is 2 inch because 3 to 2. Choose standard schedule. Your schedule will be on the ISO, but for now we just use standard all through. Yes. So for clarity, there is something we did on our stress ISO. For beginners, it's better to have to write your node at this point. We have 10 at this point, 20 at this point. That's for the flange. From 20 to 30 is our reducer. From 30 to 40, that's where we have our support. Then from that 30 to the branch, we have 40 to 50. 40 to 50 is the branch where we have the SIF. Then from here, from that point to the reducer is 50 to 60. 60 to, we have 60 to 70 as our another reducer. Then we have our spool. We have to ignore this length because, okay, we can calculate the spool length because we have this. You subtract this flange, subtract reducer, and that 89 for the equal T from 280, then you get your spool. That's it. So which is the flange is this is 89. We have the flange, 2-inch flange is 70 plus 89. Then what else do we have there? The reducer is 89 too, so we have 89 plus 89 plus 70. It's almost, the spool is very small, so 248 minus 280 minus, oh, okay, I'm supposed to press this, minus 32, press this, yeah, that's 32, it's okay. So the spool is 32 for 3-inch. You know, the spool is too small, but for the purpose of this class I just put it, but that's not acceptable spool for 3-inch line. 3-inch is 60, it's 80. The minimum spool you can have there is 80, so but let's just put 80 for the purpose of this class. So yeah, 80 mm. It cannot be less than 80 because of welding. When they are welding them, if the spool is too small, the welding will take the whole, yeah. So so we have continue. Okay. Oh, but wait, must select and record. Well, come on, recording. Okay, so we have the node numbers for our stress ISO to make it easier. 10 to 20 is the flange. This is the flange here. That's 10 to 20 is the flange. Then we have 20 to 30 for the reducer, and 30 to 40 for the support. Then 40 to 50. No, 50 is the SIF, the equal T, 3-inch equal T. Then we have the SIF, the other part of that is 89 for the other part of the SIF. This the equal T. Then we have the reducer, 60 to 70. Then we have a spool. We now have a flange. So for us to get this spool, we have the total length from the SIF to the face of flange. We'll add this together, this plus this plus this, which is 89 plus 89 plus 70. Subtract from 280, we have 32. But the spool, the length of the pipe here is 2-inch, which 2-inch is 2-inch is 60 mm. So the spool is too small. Maybe the designer need to increase this. They will point that out to the designer. So we can use 60 for the spool. We can mark it up as design. So we go back to our model and say continue. Then we have put 60 here for the spool. Then after that, that's 70 to 80. Look at our, that's 70 to 80. So 80 to 90 now. We have we say continue to create a new node. 80 to 90. We have this is why we have the valve and flanges. So just put the flange. Select the class rating. It's around 50. If it's 800, you put it was 150. Click OK. Then you have it here. So with this, but remember the SIF here. You click this line. The SIF is 50. You can copy it. This is what I normally do. But some people, before creating this, they can create that branch. But my own, I normally create the head before creating the branch. So I click here. I click continue. then I change this to 50, then change this to 200 because I want to start a new branch. I want this branch to start from 200. So and now if you look at it, it's going towards the, let's check it out, it's going toward X. If you look at our ISO, look at it, this is the branch. We don't know the length, but I will assume a length. Okay, maybe that's the length for the equal T, which is 89. Okay, so I just going towards X, I put 89. That's what you have. So you can continue to create that, but you check the size. This F5, let's check it. F5, 5, that's flange 5, is 3 inches. That means the line is 3 inches. So you come back here and change, because the reason why it's taking 2 inches because the last thing you did here is 2 inches. So it's taking 2 inches because you are continuing from here to this. So when you come here, double click so that you go back to this, change this ones to 3 inches, then this, the schedule to change it. And then once we are done with that, so create next and create your flange 150. And with that, we are done with the model. You can click save. So this takes us to the end of modeling. There are some other how to model at 45 degree. That we are still going to do that. So as soon, okay, I think we will have to stop here. In the next video we'll do that. Thank you for watching.